So I'm going to walk through a couple of problems from page 646, these tricky vertical motion problems. So remember that our model for vertical motion is that the height of an object at any time t is equal to negative 16t squared plus v sub naught, the initial velocity, times t plus h sub naught, or sometimes I think maybe I used s, the initial height of the thing. Negative 16, remember, refers to the pull of gravity on the object. Let's look at number 2. Slow pitch softball. A ball is pitched at an initial height of 2 feet above the ground and an initial velocity of 35 feet per second. So write an equation for the height of the function of time. So we just simply fill those in. The height of this softball at any time t is going to equal negative 16t squared. Remember, it's always negative 16, that's a constant. In this problem, the initial velocity was 35 feet per second, and the initial height was 2 feet above the ground. So this is the answer. This is the model for that ball, the height at any time. Part B says the batter hits the ball when it is 2.5 feet above the ground. How long after the ball is pitched is the ball hit? Okay, so let's kind of envision this. There's a pitcher on a mound here, and if you've ever seen slow pitch, they kind of bend down a little bit when they release it. The ball is released at a height of 2 feet. It's going to kind of come up in the air like this, and then it's going to be hit at a height of 2.5 feet above the ground. So here's our 2 feet. That's our initial 2.5 feet. So if you were to draw a horizontal line here, you can see that this ball is going to reach a height of 2.5 feet shortly after it was pitched, and it's going to arc up like a parabola and come back down and be 2.5 feet again. And here's our batter that's going to hit the ball. So we're looking at the path of this ball as it's pitched, not as it's hit. All right, well, we know the height of the ball as it is pitched, as it is thrown, is this, and we simply want to know when is it going to be 2.5 feet. So this is the key. We substitute this in for the height of the ball. So let's go ahead and do that. So we have 2.5 is equal to negative 16t squared plus 35t plus 2. Don't let this confuse you. Before you apply the quadratic formula, we need to set this quadratic equal to 0. So we are going to subtract the 2.5 from both sides, and we would have negative 16t squared plus 35t minus 0.5 is equal to, that would be equal to 0, right? So now this is our A, this is our B, and this is our C. And we plug those into the quadratic formula. X, or T, is equal to negative B plus or minus the square root of B squared minus 4A, get your signs right, C, all over 2A. And if you solve that equation, I guarantee that you're going to have a very small number here and then another answer which would indicate this time, and hopefully you get a time of 2.2. That's how you do problem number 2 on this page. I hope that helps you. Go ahead and try and persevere. After 3 o'clock today, I will post all the answers to these problems. Good luck.